This one is January 2023, Unit 6. We did the first two questions. So starting with question 3. In question 3, a student investigated the damping of a rotational pendulum. Means this pendulum is rotating and student is investigating the damping of this rotational pendulum. When a metal rod is rotated through an angle and release, the rod perform an angular oscillation about a vertical axis. The plastic sheet dampen the oscillation. Like this plastic sheet will cause an air resistance and that will dampen the oscillation. The relation between the maximum displacement theta and the number of the oscillation is given by n, where theta is the initial angle of displacement and lambda is a constant. Explain why if the graph for ln theta and n could be used to determine lambda. So we have this theta is equals to theta naught, the original angle, e raised to power minus lambda n. So what we do, we'll take ln both sides. So it will be ln theta is equals to ln theta naught e raised to power minus lambda n. Ln theta, when two quantities are multiplied, we write them in addition. So ln theta naught plus ln e raised to power minus lambda n. Then ln and e cancel out each other. So it will become ln theta is equals to ln theta naught minus lambda n, because this ln and e cancel out. If we rearrange the equation, we can say ln theta is equals to minus lambda n plus ln theta naught. Now, when we compare this with the equation of a straight line, so while comparing with the equation of straight line, so y is equals to mx plus c. So on y-axis, if we have ln theta, on x-axis, if we have n, if n is there, so what will be a gradient? Gradient will be equals to minus lambda, or lambda is equals to minus gradient, means this will have a negative gradient. And lambda is a constant, so means it must be a straight line. So what should be the shape of the graph? It will have a negative, and the y-intercept will be ln theta naught. So the shape of the graph, it should have a negative constant gradient. So it will be somewhat like this. And the gradient is represented by minus lambda, or lambda is equals to negative of the gradient. The student displaces a metal rod by a large angle, and he recorded the displacement angle for every 10 oscillations. Then plot a graph between ln theta and n on the opposite grid and use additional column. So because what we need, we have ln theta is equals to minus n lambda, or lambda n, plus ln theta naught. So we'll compare with y is equals to mx plus c. So y-axis we need ln theta. This is theta. So we need ln theta. So ln theta will be plotted on the y-axis. So one column is given. So we have to plot ln theta there. The unit will be degree. So we'll write degree. And then you have to plot a graph by, like, take ln of 124, ln of 182, 55, 37, 25, and 16. So take ln of each value and then you will get ln theta. Determine the value from lambda. So how you work out the value of a lambda, as I mentioned, that when you compare with the equation of straight line, your gradient is minus lambda. So from your graph, work out the value of a gradient, which is y2 minus y1 over x2 minus x1, and that will be equals to minus lambda. So you will work out the value for lambda. Student claimed that the initial displacement was greater than 180. Deduce whether. So how to deduce that? Like when you plot a graph, the initial angle, initial displacement is 180. That is the claim of the student. So how it can be done? You will work out the y-intercept after plotting a graph. between ln theta. So after plotting a graph between ln theta and n, so the shape of the graph is this. So student claimed that the original angle is 180, greater than 180. So what you have to do, you have to extend your graph and find the y-intercept. That y-intercept will give us ln theta naught. And that value, like ln theta naught, will be equals to that value, any specific value according to your graph, like example 4, 5, any number. And if you need theta, you will take a tan inverse, you will take anti-log. So theta naught will be equals to e raised to power 5 or e raised to power that number, like y-intercept, and then take anti-log because ln theta naught is a y-intercept. So if you need theta, you will take an anti-log or e raised to power because opposite of ln is e. This is a grid for the graph. Question 4. A student measure a metal ring of type as shown. The student measure the diameter of a hole of a metal ring with a set of digital calipers. State one technique reduce the uncertainty in the measurement. So student is measuring the diameter of this hole. This is what student is measuring. So when caliper is there, one is the external jaws, another one is the internal jaws. So when we want to determine the internal diameter, we have to use the internal jaws, not the external jaws. The first thing, we'll use the internal jaws of this caliper, and we will how to reduce an error. Like if we repeat the experiment with different orientation, we'll reduce the random error. But if we check for zero error, like in the beginning, check for zero error, it means we minimize the systematic error. So repeat the measurement, different orientations. It will reduce the random error. Or check for zero error before measuring the diameter, then this will minimize the systematic error. She records the following measurements for a D, determine the value and the uncertainty. So how to, first thing, whenever you check the values, check if any anomalous result is there, the result which is not in the order or in a range, you will ignore that result. But this all appear to be in the same order. So how to take an average, we will add them and divide it by 4. So this will give us the average diameter, which will be 8.54 millimeter. But how to work out the uncertainty? Uncertainty is a maximum minus minimum divided by 2. This is also called a half range. So maximum value and the minimum value. So 8.56 minus 8.53 divided by 2. This will give us an uncertainty in the measurement of a diameter, which is 0.02. The student was given a metal ring of different size. She measured the distance D as distances as shown. She calculated the shaded area A for a metal ring using a formula. Show that the uncertainty in D square is about 1 millimeter square. Look, how we can work out, because we have to show it is about 1 millimeter square. So whenever like power is there, so uncertainty will, but when two quantities have a different unit, first thing what we have to do, we have to work out the percentage uncertainty. So first we'll work, we cannot directly mention the uncertainty. Why? Because area unit is meter square and diameter unit is millimeter in the question, or you can convert into meter. But even if you don't convert in the units, because if you're taking a percentage, it won't make difference. Because in percentage, if I calculate the percentage uncertainty in the units of millimeter or meter, it won't make difference. So first we'll work out the percentage uncertainty in D. What is the percentage? 0.06 divided by 10.7 into 100. This will give us a percentage uncertainty in D. which is 0.55%. Then what is the percentage uncertainty in D square? So 0.55 multiplied by 2, so it will be 1.1%. That is a percentage uncertainty. Then what is the uncertainty in D square? So we have the formula: percentage uncertainty is uncertainty divided by the value recorded into 100. So percentage uncertainty in D square, because we are finding the uncertainty in D square. So percentage uncertainty in D square is 1.1. Uncertainty we don't know, and the value which we recorded was 10.70 into 100. Cross multiply. So 1.1 multiplied by 10.70 divided by 100. This will give us uncertainty in D square, which is about 1.26 millimeters square. So which is about 1 millimeter. And there's also another way to do the same question. After working out the percentage uncertainty in D square, you can work out the maximum and the minimum values. This is one way, as I mentioned. Another one is after working out the percentage in which is 1.1. So work out the maximum value, add the uncertainty and work out the minimum value. And then maximum minus minimum divided by 2. You will get the percentage. You will get the uncertainty. So both ways will give the same result. Show that the percentage uncertainty in A is about 0.4%. So look, how A is calculated. A is pi is there and 4 pi is constant. 4 is also constant. So they don't have any uncertainty. The value of the pi and the value of the 4 both are constant. Then there is an uncertainty in S square and there is an uncertainty in D square. Uncertainty in S square, so uncertainty in S square is we can like uncertainty divided by value recorded into 100. D is already we calculated. So uncertainty in D was 1.1%. And what about uncertainty in S square? Because the two parts are related and it's a 4 mark. So we have to show that the uncertainty in A is about 0.4%. This is how A is calculated. A is calculated by using a formula pi by 4 S square minus D square. So what we can do, and this is directly the uncertainty, like uncertainty of S square is given. The value of S square is given and the uncertainty of S square is also given, which is 2 millimeters square. And for D, we worked out this is the value for D and this is the uncertainty in D, and then we already worked out the percentage uncertainty. So we can work out the percentage uncertainty in S square, percentage uncertainty in S square, which is 2 divided by value recorded 881 into 100. So this will be 2 multiplied by 100 divided by value recorded 881. So this will give an uncertainty of only 0.22%. And what is the percentage uncertainty in D square, which we worked out? It was 0.06 divided by 10.70 and multiplied by 100, and then the total is multiplied by 2 because this D is given. So D square, that was 1.1%. So, and the total factor is this is 0.22% plus 1.1%. So when we add 1.31%, and this 1.31% multiplied by the 3.14, so 1.31 multiplied by 3.14 and divided by 4. So 1.31 times 3.14, and so value of the uncertainty always add up. So we got the uncertainty, addition of the uncertainty of s square, which is 0.22, and the uncertainty on the d square was 1.1%. So we got this total as 1.3%, and 1.31, like 1.31 divided by 4, which is about, because the factor is there, pi is a constant, and this total is divided by 4. So if we divide by 4, we get about 0.32%. This is one way of getting the final answer. Another way, what you can do, you can work out, this is one way of finding like uncertainties. Like first work out the uncertainty in s square and then d square, and then calculate the uncertainty in a, just the second thing what you can do is work out the maximum and the minimum values for a, and then maximum minus minimum divided by 2, that will give us the uncertainty, and uncertainty divided by the value recorded into 100, like the mean value or the average value, into 100, like the second method. And it's a 4 marks, so better to do with the second method, because the second method is in which we separately solve each. So what will the maximum value of a? The maximum value of a means when we use, this one is a equals pi by 4 s square. The maximum value of s square will be 883, because we'll get a maximum value when s square is greater and d square is smaller. That will have be the maximum value. And when we'll have the minimum value, when s square is less and d square is more. So value of s square is 881 minus the value of a d, it will be 10.7 minus 0.06, which is 10.64. So 10.64, and but this is d, so d squared should be squared, and then you will substitute the value. This will be maximum. What about the minimum value of a? Minimum value of a when this s square is small and d square is large. So pi s square is small, means minus, like it will be 879 minus, and this will be large, like 10.7 plus 0.06, which is 10.76. So this will be 10.76 and then square, because this is value of a d, we need d. So this will give us a minimum value, maximum and the minimum value. So maximum value 605 meters millimeter square. Minimum value 600 millimeter square. How to work out the uncertainty? Uncertainty is maximum minus minimum divided by 2. So maximum minus minimum, maximum is 605 minus minimum is 600 divided by 2. This will be give the uncertainty in A, which is 2.5 millimeter square. And then what we need the percentage uncertainty. So if we need the percentage, we have two values. So percentage uncertainty will be uncertainty divided by mean, because we have two values into 100. So it will be 2.5 divided by average 600, and it will be 602.5 and into 100. So when you work out the percentage, it will be about 0.4%. Is it clear? The student measured the total mass of 10 identical metal ring, which is 63. Explain why measuring a total mass is better than measuring a single. So, look, percentage uncertainty is uncertainty divided by value recorded into 100. When we record like for a longer lens, greater amount, so value recorded will increase. If the value recorded increase, the percentage uncertainty will decrease. So both will, even if we record for single measurement or for 10 measurements, the uncertainty as we are using a same instrument, it will be same. But as we record a greater value, which reduce the percentage uncertainty in the mass. Uncertainty changes if we change the apparatus. Student, she measured the total thickness and determined the density using this. Then determine the mean density. So you how to work out the mass is there. This is a mass for a 10, and this is a the total thickness for the 10, and area is there. So total thickness for the 10 is given, the mass of the 10 is given, and the area of each is given. The cross-sectional area like this. So if you need the density, density is mass over volume, and volume for a cylinder, it will be area into height. So you can just take the mass of, because look, density for 1 and density for 10 won't change. It will be same. And we need an average density, so we need the total density. But don't forget to convert the unit, because here it is gram per centimeter cube, but here the thickness and the area are in, like it is in millimeter, and this is millimeter square. So we have to convert them into, so this will be 63. Area is millimeter square. Look, if you want to convert the millimeter into meter, you divide it by 1000. But this is millimeter square to meter square, sorry, centimeter we want to convert, because the final centimeter. So millimeter to centimeter, you divide it by 10. But millimeter square to centimeter square, you divide by 10 square. So area will be 602 and divided by 10 square. This will convert into centimeter. And the thickness is 14.03 divided by, because we have want to convert into centimeter only, so this will be divided by 10. So this will give us the average density or the mean density of this stack. So unit conversion is important. Don't forget to convert the unit, which will be about 7.46. This stainless steel ranges from 7.48 to 7.95. Deduce whether the metal ring could be made from a stainless steel. So what you can do, you can compare the percentage uncertainty with the percentage difference. So how to work out the percentage uncertainty? The values are given. So if you want to work out the percentage uncertainty in the density, so percentage uncertainty in density, that is how density is calculated, mass divided by volume or area into the thickness. So find the percentage uncertainty in mass, find the percentage uncertainty in area, and find the percentage uncertainty in thickness and add them, because uncertainty always add. And percentage uncertainty will add, as we said. So if we want to work out for a mass, the uncertainty is 0.5 and the value recorded is 63 into 100. These are percentage uncertainty in mass. Then the percentage uncertainty, and even it's already area, it is already 0.4, so directly 0.4, and for thickness 0.04 divided by 14.03 into 100. So this will give us a percentage uncertainty, which is 1.1%. Then work out the percentage difference of the two values. Like the range is there. So what is the percentage difference? Percentage difference is maximum minus minimum divided by the like mean into 100. Or you can also use this the standard value. This is our answer for the last one, the 7.46. So we have like 7.48 is like any one of them we can, because we want to compare the difference, percentage uncertainty in the density we have. We want to get the percentage difference. So percentage difference, we can calculate the percentage difference of our value with the lower limit or the higher limit. Any, but it is closer to the lower limit. That's why we are taking a percentage difference from the lower limit. Higher limit, it will be obvious the greater value will get. So it will be maximum minus minimum divided by mean into 100, or maximum minus minimum divided by standard value into 100. So maximum is 7.48, minimum is 7.46, our value divided by standard 7.48 into 100. This will give us the percentage difference, which is 0.3. So you compare the percentage difference with the percentage uncertainty. So percentage difference is smaller than the percentage uncertainty. So means, because look, if the percentage uncertainty is more than the percentage difference, it means the two values are equal. But if the percentage difference is greater than the percentage uncertainty, means the values are not equal. So here the percentage and total percentage uncertainty is higher than the percentage difference. It means that it can be made from the stainless steel. Is it clear, this one?